Hello everyone, good morning, good afternoon, or good evening. Today I will be presenting an important topic in graph theory. It's a random graph. Our discussion will cover the basic of a graph theory, the historical development of random graph, their applications, and some key property and implication of this model. So let me introduce myself. My name is Ari Zakkai Panggulu, and my name is 221011060031, and I'm from Information System Class A. So, we start with introduction. Graph theory is a branch of mathematics that study the properties and structure of graph. A graph is a collection of vertices, also known as nodes, and edges that connect pairs of vertices. Graph theory has application in various fields, including computer science, biology, and social science. Historical background. The concept of graph dates back to 1736, when Euler solved the famous Königsberg bridges problem in Europe. In the 1959, Paul Erdős and Alfred Rényi introduced the concept of random graph, which are graphs generated by some random process. This marked a significant advancement in the study of networks and their behaviors. Definition of random graph. A random graph is defined by two parameters, the number of vertices and the probability p that any given pair of vertices is connected by an edge. This is denoted as G in bracket N and P. The Erdős-Rényi model is a classic example, where each possible edge between n vertices is idempotently included with a probability p. Applications of random graph. Random graph models are used in the various fields. For instance, 1. Social network. They help study the spread of information and identify key influencers. 2. Biological network. They aid in understanding protein-protein interactions and gene regulatory networks. 3. Communication networks. They analyze data flow and identify vulnerabilities in network infrastructure. 4. Financial networks. They model risk propagations and help manage system risk. 5. Power grids. They analyze the stability and resilience of power distribution systems. Properties of random graph. Random graph exhibit several important properties, such as degree distributions, the presence of a giant component, low clustering coefficient, scale-free property, and varying connectivity based on the model used. These properties help us understand the behavior of complex networks. Next is advantages and disadvantages. While random graph models provide valuable insight and predictive power across multiple domains, they also have limitations. They often simplify real-world networks, which might overlook specific features, and their accuracy can be highly sensitive to the chosen parameters. Additionally, large networks can present computational challenges. Next is conclusion. So, in conclusion, random graph models are a powerful tools for studying complex networks. They offer significant practical implications for optimization, risk management, information dissemination, and biomedical research. The future potential for this model includes broader data integration and improved dynamic modeling to better capture real-time network changes. Thank you for your attention. I hope this presentation has provided you with a clear understanding of random graph and their importance in graph theory. So, thank you very much.